Welcome user. In the last video we have completed how to perform k-means in the MATLAB. In this video we are going to see how hierarchical clustering helps us to perform grouping. Both k-means and hierarchical clustering do the same thing, but approach to make clustering is different. In this video we will see theory behind hierarchical clustering, and in the next video we will see MATLAB implementation of the hierarchical clustering. So let us begin. To perform k-means clustering, we have followed certain steps, and we have done clustering by using mathematical as well as by using graphical approach. For hierarchical clustering also we follow certain steps to do grouping. Over here you can see steps we follow to perform hierarchical clustering. In the first step we are going to consider each data point as a cluster. In the next step we are going to combine two closest clusters to make them one cluster. Repeat step number 2 until we will get single cluster. First, let us do clustering by using graphical way, and after that we will see mathematical approach to make clusters. Suppose we have some data points, and if we map those data points on a scatter plot, we can see data points with no grouping. But after applying hierarchical clustering, we will be ended with such diagram, which will be identical like k-means clustering. Now the question is how we are going to determine closeness of clusters. There are so many approaches. The first approach we can use minimum distance. In this approach, we are going to see minimum distance between two data points, and those data points are belong to different clusters. This approach is called as a single linkage approach. The second approach we can use maximum distance, also called as a complete linkage method. In this method, we are going to consider maximum distance between two data points, and those data points are belong to different clusters. Also, we can use average linkage method. In this method, we are going to take average by calculating distance among data points. So according to first step, we are going to consider each data point as an individual cluster. After that, we can see these 2 points are close to each other. So we will make these 2 points as a single group. After that, again we will check. This time we will combine these two clusters. If we repeat the same steps, we will be ended with such diagram, and this diagram show hierarchy of clustering. We can visualize same hierarchy by using dendrogram. Dendrogram is a kind of memory that will show steps that we carried out during hierarchical clustering. It is a plot of distance versus dataset points. So in this diagram, I found distance between these two clusters are minimum. So in the dendrogram, I will connect these 2 points. After that, I have added this point to this grouping, and I will connect respective point in the dendrogram also. I will repeat the steps, and I will be ended with the final dendrogram. In the dendrogram, y-axis will show Euclidean distance between two clusters. Euclidean distance will measure how these 2 points are dissimilar. Now we can easily decide how many clusters we want just by creating hypothetical horizontal line. Suppose we want 3 clusters, so I will make hypothetical line over here, and respective y-axis will decide threshold value of distance. But in the case of k-means, we have seen how to decide optimal value of clusters by looking into the elbow plot. So the question is, in the hierarchical clustering, is there any way that will provide optimal number of clusters? Yes, by looking into dendrogram, we will get optimal number of clusters. So in the dendrogram, check long vertical line that will not be crossed by any hypothetical horizontal line. So over here we can say this vertical line is long line, and this vertical line is not crossed by any hypothetical horizontal line. And the respective distance point along this vertical line we will consider as an optimal value of clusters. So this is a graphical way we can consider to make clusters. But suppose data is denser. For such data, it is impossible to perform grouping by looking 2D plot. So let us see mathematical approach to do clustering. Over here I have considered one random data set contain 4 points. According to the first step, I will consider each data point as a cluster. Now in the next step, I will calculate Euclidean distance between each data point with respect to all other remaining data points. Right here you can see how I calculated distance between data points. And right here you can see distance matrix of the data points. By looking into matrix, I can say the point P3 and P4 are the closest, and we can make group of these 2 points. I have considered single linkage method, so I have looked for minimum value between 2 clusters. Now in the next step, I am going to update distance matrix. Over here you can see I have calculated minimum distance between new obtained cluster and older individual clusters. So the first step will define that we are going to use single linkage method, and that will find out distance between P3, P4 and P1. In the next step, we will look distance between P3 and P1 and P4 and P1. And after that, in the last step, we will consider minimum distance between the 2 points, that is 2.23. I will repeat above steps for each data points, and at the end, I will get updated distance matrix. Now I can make grouping of P3, P4 cluster and P1 cluster. I will repeat the steps, and finally we got such grouping, and we have done grouping. Also, you can see grouping created by using dendrogram. Over here, by looking into dendrogram, we can see step-by-step approach of grouping. This will end our video. In this video, we have done conceptual analysis of hierarchical clustering. In the next video, we will see how we can perform hierarchical clustering in the MATLAB. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments and get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future. MATLAB is our future. Happy MATLABing.